Hi guys, welcome to the Support Vector Machines project overview lecture. Let's train and deploy Support Vector Machines model on another dataset from UCI Machine Learning repository. This real dataset concerns credit card applications. All attribute names and values have been changed to meaningless symbols to protect confidentiality of the data. You can download the data file from the UCI Machine Learning repository or use the one which is processed and provided in the course material. Later on, you can work with the unprocessed data file from the UCI website and do the data cleaning yourself to practice your skills. So the first thing he's asking for, he's importing some important libraries and then read the data file and display the head of your data frame. The data file is provided and you need to read and display the head of your data frame. Then he's asking to display the information on your data frame, which is a quick summary, 690 entries and 14 columns. Here he's asking to display the basic statistics of your data. So you need to call the function to display the basic statistics of your data frame. Then moving on to the EDA, exploratory data analysis. He's saying the features are hidden and renamed with some x1 to x13. We can do the pair plot, but this would be big. Let's do some assumptions and explore the data. Please note, all the EDA is after assuming a specific feature for specific column. This is not true, and assumptions are made for practice the EDA skills only. So if you want, you can create a pair plot and the code is already given, but this is not required. The first question in EDA, he is asking for how many persons could get approval. So you need to find out how many people got 0 and how many people got 1. You can assume 0 for no and 1 for yes. Next question is, considering X8 as a sex, male 1 and female 0, which sex have better chances for credit approval? Recreate the plot below. So you have to recreate this plot, which is a count plot and target is along x-axis. Moving forward, considering X4 as a credit score, which score is the highest number of counts? Recreate the plot below. So you have X4 along x-axis and count along y-axis. You need to recreate this plot. Once again, with our assumptions, X8 sex and X4 credit score, what is the probability for male and female to get approved if the score is greater than 7? Create a count plot, please. So you have to recreate this count plot where target 0 for blue and 1 for green. So the next question he's asking for looks like X1 is age. Let's assume it is. What age is the common for people to apply for credit? Create the plot below. So you have to recreate this plot. Blue is for approved and this orange type is for not approved. So moving forward, the next question is, considering X12 is amount in thousands, how X1 and X12 are related? Create a joint plot. So you have to recreate this joint plot. You have X1 along x-axis and X12 along y-axis. And we are assuming that X12 is in thousands. So moving forward to the machine learning part, do the train test split, use test size 0.30 and default value of random state at the moment. The next one is importing and training the support vector classifier. Import SVC and create its instance, svm_model. Then train the model, please, and do the predictions. Finally, he's asking for how the classification report and confusion matrix look like. So if you are using the same random state and same test size, you will get the same results. So moving forward to the grid search, and parameter values are given, and he's asking, do the grid search to find optimum value of C and gamma. Please do not use verbose at the moment. The next question he's asking for, you may want to know the best values of your parameters. So you need to display the best values of your parameters. Then do the predictions using best values of your parameters and print confusion matrix and classification report. So this is your confusion matrix and this one is your classification report after grid search. So you will see that the model is improved after grid search, but still the predictions are not great. I want to mention here that in the professional setup, you try different strategies, including feature engineering along with using different models to see which one works best for your data. This section is specifically for SVMs to learn how the model works and how to improve its performance. As always, I recommend you guys try to solve all these questions yourself before you move on to the solution lecture. I'm sure you would be able to find out the solutions for all these questions at this stage. So, see you in the next lecture, which is the solution lecture to this project. Good luck.